Let us see phasor of transformer. For drawing phasor, we require circuit representation of transformer. So circuit is shown here based on LV side and HV side, and our circuit elements and parameters are represented in this. And based on this, for primary side I can write the voltage equation V1 equal to minus E1 plus I1 R1 plus J I1 X1, which can be written as minus E1 plus I1 R1 plus J X1 also. And we know R1 plus Jx1 is impedance of primary side, so it can be written as minus E1 plus I1 Z1 also. So this is voltage equation for primary side, and for secondary side also we can write E2 bar equal to I2 R2 plus J I2 X2 plus V2. So I can write it as V2 plus I2 R2 plus J I2 X2, which can also be written as V2 plus I2 Z2. We know I2 will be common and R2 plus JX2 will be secondary impedance Z2. So based on this, we can draw the phasor. Let us draw phasor for unity power factor. Okay, so let me take reference as phi, or magnetizing current. So here we have phi. We know by old convention EMF induced will lag this flux. So this is locus of E1 and E2, and this will be locus for minus E1. So voltage and EMF equation for secondary side, we know E2 is written as V2 plus I2 R2 plus J I2 X2. So keeping this in mind, I can draw V2, which will lag E2 by some angle. So E2, this will be locus of E1 and E2. So V2 I am drawing from here. So this is V2. And for unity power factor, if load here is unity power factor, so current in that is I2 and V2 will be in phase. Therefore I2 I am showing in phase here, and I2 dash will be anti-phase of I2, and that will be shown here as anti-phase. So this is what I2 dash. We know I naught locus is somewhere here. I naught is combination. We know I naught is IC plus IM, and we also know that I1 phasor is I2 dash phasor plus I naught phasor. So we have I naught and I2 dash, their phasor sum, so will be I1, and that can be shown by completing this parallelogram. So this current is I1, right? Now V2 is shown here. So for completing this phasor, V2 plus I2 R2, I2 R2 will be in phase with V2, and I2 X2 will lead V2 by 90 degree, right? So I2 R2 will be here in phase with V2. Say this is I2 R2 and I2 X2 will lead I2 by angle 90 degree. So this is what? This is J I2 X2 and this value will be V2 plus I2 R2 plus J I2 X2 is what? E2. And here we have somewhere E1. So this will be antiphase minus E1. So primary side voltage equation V1 is minus E1 plus I1 R1 plus J I1 X1. So E1 is located here and I1 R1 must be in phase with I1. So I1 locus is here and I1 R1 must be in phase with this, and that must be drawn from the tip of this E1. So here it is I1 R1 and this is in phase with I1, and from here we can show I1 X1 which must lead it by 90 degree. So this is what this value is J I1 X1 and minus E1 plus I1 R1 plus J I1 X1 is nothing but V1. See, so we can finish it like this. It will be V1, right? So this is our phasor diagram for unity power factor, and angle between V1 and I1 will be primary power factor angle, that is phi 1, and load is unity power factor, so angle between V2 I2 is 0, right? We can show impedance triangle also in this. So impedance triangle Z1 is I1 R1 plus I1 X1 is I1 Z1. Similarly, I2 R2 plus J I2 X2 is I2 Z2. So I can show here. This is what? This is I2 Z2. So that's all about a phasor of transformer at unity power factor.